We now want to talk about applications of linear equations. In other words, real-life situations that we can use linear equations to answer questions about. To do that, we're going to have to take real information or information presented in language, English language, and transform it into mathematical or algebraic language. So here we have a few examples of doing that. Our first example, 8 more than a number. When I say a number, I mean some number whose value we do not know. So we can translate that as a variable. I could call it n for number, or x, y, t, rabbit. It really doesn't matter what we call it so long as we know that it represents an unknown quantity. Now 8 more than that quantity represents starting with that quantity and increasing it by 8. That would mean to add 8. So 8 more than a number is represented as the algebraic expression n plus 8. Notice that if we knew the value of the number, we would know the value of the whole expression. For example, if n were 5, then 8 more than 5 would be 13. And here we see 5 plus 8 equals 13. The next example, 5 less than a number. So we start with our number, I'll call it x this time, and now we want 5 less than that, which means we're decreasing our number by 5. Therefore we subtract x minus 5. 45% of a number. Well, our number is our variable, and to get a percentage of a number, we need to multiply by that number. And remember, 45% as a decimal is 0.45. This is one of our key words that will really help you. Oftentimes when we see the word of, it means to multiply. Not always, but often, especially when we're talking about a percentage of something or a fraction or a part of something. Finally, 19 minus twice a number. Here's 19 minus twice a number means some unknown number that we double. Double means multiply by 2. 19 minus 2n. Now that we have discussed converting English phrases into algebraic expressions, we need to talk about turning English phrases or sentences into algebraic sentences, which we call equations. Because in order to answer the question, our general practice will be to turn the information into an algebraic equation. Then we solve the equation, and we can use the solution to answer the original question. Here are 2 examples. The first one, a number decreased by 6 is 1/3 of the number. Okay, so first, a number decreased by 6. If our number is x, then a number decreased by 6 means x minus 6. Is means that it is equal to what we say next. And anytime we have a word that makes 2 quantities have the same value, we can translate that as equals. So is, are, make, will be, produce, anything of this nature, we can translate as an equals symbol. Now, what is it equal to? 1/3 of the number. 1/3, and to get 1/3 of the number, we multiply by 1/3. Using the same variable because we're talking about the same number. And so there's an equation, and now we can solve it. We can multiply on both sides by 3 to get rid of the fraction. And so distributing the 3 here, we will have 3x minus 18 Over here we'll have x. Now, subtracting x from both sides, we have 2x minus 18 equals 0. Adding 18 to both sides, we have 2x equals 18. Dividing both sides by 2, we get x equals 9. So our unknown number must be 9. And does that make sense? Is it true that when we decrease 9 by 6, that's the same as taking 1/3 of 9? Yes, it is. Because decreasing 9 by 6 gives us 3. And taking 1/3 of 9 also gives us 3. The next example says the product of 7 and the sum of a number and 6 makes 14. Kind of wordy, but we can sort our way through this information. First, the product. Product means multiply. In normal English, product can mean the result, and so we might think equals, but this is a math-specific term that means to multiply, just as sum means to add, difference means to subtract, and quotient means to divide. The product of 7 and the sum of a number and 6. So we're multiplying 7 by the sum. So 7 times the sum. What sum? The sum of a number and 6. Now remember, sum means to add. So we're taking our number and we're adding 6. But we have to multiply 7 by the whole sum. And so we show that by including these parentheses. Without them, I would simply be multiplying 7 by the number. And what does this make? This makes 14, which means that should all be equal to 14. And now we can solve this equation. Distribute the 7. 7n plus 42 equals 14. Subtract 42 from each side. We get 7n equals negative 28. And divide by 7. And we get n equals negative 4.